Hello everyone, greetings. I welcome you for the case study video on total quality management. So here in this session, we are going to discuss about the case study on Kaizen. So before discussing about the case study on Kaizen, uh, we are we supposed to know what is Kaizen, what are all the advantages of following Kaizen. Then afterwards, we need to discuss about the few industrial case studies about the case. So let us discuss what is case. So Kaizen, it is a Japanese word. It is coined from Japanese language. So the native of this development of this technology is from Japan. So K and Zen. So stands for change and Zen stands for good. So we are expecting good change from the existing one. So that is what about the Kaizen. So here, this is the industrial philosophy we are following. Most of the industries, whatever the industries may be, it is the service related industry or manufacturing related industry, we are following this technology. It means we are already having some kind of existing technology. So we need to adapt minor changes in the technology or minor modification in the design of the component so as to the component perform well or to improve the productivity of any manufacturing operation. So that is what about the basic theme of the case. So from the existing, we need to do slight modification in the design or the technology or the process or the steps. So will improve the process which we already having the existing technology. So that is the basic concept. So as I mentioned earlier, it is the Japanese word. It defines, especially for the management roles, so we are continuously encouraging and implementing the small improvements, which is involved in everyone. So we have a factory or industry. Most of us working for any process or product development. So we need each one of uh, involvement of each one of who has to improve the productivity of the company. So this is the Kaizen wheel, uh, which which is followed by the Japanese people. So this wheel describes about the non-value added activities. So here the letter muda, muda is the Japanese word which indicates non-value added activities for the process. So here, the first muda is it is caused by overproduction because sometimes we are not aware of the production schedule. We are producing excessive components. So this is the value added, non-value added activities. Mostly we have to avoid. Then muda caused by unnecessary stock. So we are maintaining inventory stock in the stores. So we have to order what we require. So we already have various technologies with just in time JIT. So lot of latest technologies are there. But instead, if you are overstocking the uh, component or any material which improves the which increases the inventory cost, then muda caused by defects or rejections. So if you are not following the rules and regulations, what will happen are the control instructions. So the unnecessary non-value activities can be done because of the rejections. So the rejections is highly inert in nature, which drastically reduces the profit of the company. Then muda caused by unnecessary movement. So we need to reduce the movement involved by the man or what person because it increases the productivity. Unwanted movement, we cannot get the benefit or outcome from the person. The muda caused by the inappropriate process. Processing can be done as per the control instructions in a proper way, If it is not followed properly, what will happen? It becomes a non-value added activity. So it is inappropriate processing. Again, we need to process. Then muda caused by waiting. Sometimes lack of manpower, lack of machines, lack of problem solving skills. We are waiting for someone to attend that problem. The waiting time is very crucial, which reduces the productivity of the company and reduces the profit of the company. So it is a non-value activity which need to be reduced. Then finally, muda cost by transport. So the transport, so we need to install instruments or machines where the resources are available. So once we setting the factory during erection of machines, we must ensure all the resources are available. That is proximity to the machine. Then only we can ensure that uh, all the activities will be a valuable activities. So this can be set out by standardize the workforce. Then we can get the progress. So now we'll discuss the case studies. So this is the Kaizen one or the first case study. So this is the submersible uh, pump assembly used in the submersible pumps. So in the existing, the problem is the material for manufacturing this assembly is made up of steel. The weight of this part is around 3.87 kg. So for loading and unloading of this part in a machine or during assembly, it will take 12 seconds. So because of huge weight, the workers may be reluctant to work, and the person who is involved in assembly operation and machining operation of this part, uh, they may have high fatigue due to this overweight of the part. So during Kaizen process, we are making minor changes without affecting the functionality of the part. What we are doing is the material, the steel is replaced with the aluminum. So we are already aware of that aluminum is the lightweight material than the steel. So when we compare with that volume, the weight is reduced to 1.35 kgs. So the loading and unloading, since the weight is reduced, for loading and unloading, it takes only 8 seconds. The previous one, 12 seconds. So there is a drastic change in the loading and unloading time, so which leads to low fatigue to the operator. So this kind of small changes can be implemented, even though 3 or 4 seconds difference. Uh, if you accumulate for, say, for example, 100 components produced for per ships, so we may get 300 seconds or 400 seconds time saving. So it is very big number. So this is how the Kaizen can be achieved in the any product or process development. So which saves the cycle time, also saves the inventory, uh, and foolproofing system is also implemented in this part so that we can ensure that increase in productivity. And now we are going to discuss about the second case study. So this case study is about the piston rod. So initially this piston rod is clamped in the clamp by means of manual. So during clamping, so we need to arrest all the degrees of freedom. The operator may have to give high force to clamp this part. Since the operation is manually, the operator tends to fatigue because of high cycle time. It will take 72 seconds to clamp the part. So here, uh, this manual clamping method is changed with automatic clamping machine with the assistance of uh, pneumatic cylinder. So where the compressed air is used to expand the cylinder so that the piston moves downwards, which is used to clamp the piston rod. So this, since this is an automatic process, the cycle time is about 60 seconds. Almost 12 seconds is saved. So if you add this as a cumulative value, say for example, 100 components, it becomes big in number. So it increases the productivity of the part. So the cycle time, inventory, and reduction, changeover reduction time is reduced. So this is how this uh, Kaizen system is implemented in the company to improve the productivity. And these are all the references for this presentation. One is Westerfield Water Quality Management, uh, the year of 2016, and another is Water Quality Management by Dr. S. Kumar, Lakshmi Publications, the year 2006. So I hope this case study, industrial case study video is useful for you. Thanks for watching this video.